Okay, good morning. So today we're going to do gay-lussac's law, and I just found out that I could add Snapchat filters to my recordings, which is great. Gay-Lussac's law relates temperature and pressure when moles of gas and volume are constant. Um, your temperature has to be in Kelvin, so make sure that you change that every time. Gay-Lussac, when I googled him, these pictures came up, and I just thought it would be funny to make one of these collages, so you're welcome. By the end of this, you should be able to relate temperature and pressure and solve your formula for those variables. So P1 over T1 is equal to P2 over T2. And when you look at this, if you increase your temperature, here we've heated it up, then your pressure should go up. Here's how the graph looks. Pressure, temperature, both should go up together. For your temperature conversions, if you want to go from Fahrenheit to Celsius, 1.8 times your temperature Celsius plus 32. And if you've got Celsius and you want Kelvin, you add 273. If you're given Celsius and you want to go to Kelvin, you subtract 273. Or Kelvin and you want Celsius, subtract 273. I'm sorry. Here's your formula that you should be able to rearrange. A gas has a pressure of 2 atmospheres at 18 degrees Celsius. What is the new pressure when the temperature is 62 degrees Celsius? So here you're going to plug in your pressure 1, 2 atmospheres, temperature 1, 18 degrees Celsius, add 273 to get 291 Kelvin. P2 is your unknown. Your second temperature is 62 degrees Celsius. You're going to add 273 to get 335. Notice your Celsius, change to Kelvin, we did. List your unknowns, list your given. Now you're going to solve your formula for your unknown, which is P2 in this case. If we solve for P2, then that means that we're going to multiply both sides by T2 to cancel this one out. Now you have P1, T2 over T1. From there, you just plug in your numbers. P1, T2, T1, 2 times 335 divided by 291 is equal to 2.3 atmospheres. Use gas laws to complete with increases or decreases. If your temperature decreases, then your pressure will decrease. If your pressure increases, your temperature will increase. Pressure increases because your temperature went up. Pressure decreases because your temperature went down. You can look at this to get a relationship even if you haven't changed it to Kelvin. You can still tell that the temperature is decreasing, so your pressure will also decrease. But to get an accurate number, you're going to have to change to Kelvin. Here's another problem. The gas has a pressure of 0.750 atmospheres. That's P1. 128 degrees Celsius would be T1. Change it to kelvins. What is the temperature? So that means T2 is unknown if the pressure increases to 1.5. So you know your temperature should go up because your pressure went up. And now you just solve your formula for T2, which I've done here. Cross multiply. So P1 T2 is equal to T1 P2. And then you divide by P1 to get T2 by itself. So divided by P1. Now I have T2 equals P2 T1 over P1. Plug your numbers in. 1.5 atmospheres times 401K divided by 0.750 equal to 802 Kelvin. But it asks for your temperature in Celsius, so you've got to subtract 273 to get your answer in Celsius. So you had to change it to Kelvin and then change it back because the question asked you to. Vapor pressure is when you have liquid molecules in a liquid. Some of the particles escape just kinetic energy. They evaporate, so they would be coming out. But you also have the gas ones condensing back down, cooling down into the liquid. The vapor pressure is when your particles coming out of solution and the particles going into solution is happening at the same rate, which is called equilibrium. May not be the same number, but it's the same rate. And that would be the pressure over your liquid at that point. There's a link to a really good site here in the notes that you can go click on if you want to see some more about vapor pressure. Vapor pressure is the pressure above the liquid, so that's coming from those particles that evaporate. And boiling point is when your vapor pressure equals your external pressure. So when you have the same amount of pressure going out as pressing in, bubbles are able to form, and those molecules can come out as gas. Here's the vapor pressure of water. You can see that it changes with temperature. So as you increase the temperature, your vapor pressure increases also. It's because there are more molecules coming out to counteract that atmospheric pressure. This is a problem that several people missed on the last section, and it was because you guys forgot to change your temperature to Kelvin. So that was just one that I put in here because several people missed it. V1 equals, or V2 equals V1 T2 over T1, but you had to change these to Kelvin to get the correct answer here. Okay, well, I hope that helps. Let me know if you have any questions.